Good morning and welcome again to my channel. Today we'll be solving another LeetCode question, question number 230, kth smallest element in a binary search tree, and it is marked medium. Okay, so let's see what the question says. Given the root of a binary search tree, an integer k, return the kth smallest value one index of all values of the nodes in the tree. So that means it basically wants us to return not the smallest but the kth smallest. So if the value of k is 2, we have to return the second smallest number. If the value of k is 3, we have to return the third smallest number. These are the two examples given in the question, the first one and the second one. What do we need to do to solve this question? Logically, and how would we find the kth smallest number, right? Let's say we have a list of numbers, something like 7, 8, 5, 1, 2, 3, right? And out of these numbers I want to find the, let's say, k equal to 3. So I want to find the third smallest number, right? Out of all these numbers I want to find the third smallest number. What's the best way to do it? Like, go from the smallest, right? So we'll arrange this in an ascending order. Right, now if you want the third smallest number, what is the third smallest number? 1, 2, 3. So that means this is our third smallest number. Similarly, if you want the fifth smallest number, 1, 3, 4, 5. So this is the fifth smallest number. So that's what we need to do. We need to traverse the binary search tree in a way so that we traverse in an ascending order. Basically, we want to traverse the binary search tree in an ascending order. So like, so this is the binary search tree. You want to go from 1, then 2, then 3, then 4. Similarly, 1, 2, 3, 4, 5, 6. In this one, you might have noticed a pattern. It is an in order traversal of the binary search tree, right? And also, if anyone doesn't know, binary search tree will always have the left number to be a smaller number, right? So that means our first primary target is to reach the end of the left subtree. If you see here, this is the left subtree, and this node is the smallest, not this, even though it is a layer down, but it is on the right side, right? So this is the leftmost node, if you see. So this will be the smallest node. Similarly, in this, if you see, this is the left subtree, this is the leftmost node, and it is obviously the smallest. So what we need to do is an in order traversal, right? Let's write the code and we'll do the dry run after that. That will make it clear. Okay, so yeah, so in order traversal is pretty simple. Count 0, result 0. Now, if the node that we are getting in the DFS function is nil or null, we can just return simply, right? So if node is nil, will return. If not, as I said, the first thing we need to do is reach the leftmost node. Okay, imagine you're standing here and you want to go left. So what do? Go left, then again left, and then again left. So that means for every recursion we are just trying to go left, right? So DFS of dot left, simple. Traverse left. Now when we get out of this, when will we get out of this? We'll get out of this at this point, right? Because every point we are moving left, right? Here we went left, we went left, we again went left. Here also we went left, but we reached a nil value, so we returned and we are in this state, right? Now since we have returned from this part and we are this here, what we can do is we have reached the leftmost node. We are currently sitting here, we have reached the leftmost node, and we can now do the counting, right? We want to count, like this is the first one, this is the second one, this is the third one, right? So for that we'll do count plus plus. Okay, so that means we have reached the leftmost node. Now we want returning, so we'll do a count plus plus, and we'll check if count is equal to k. That's the value we want, right? So we'll say result equal to node dot val and return from here as well, right? Now if it is not, we have increased the count, right? If it's not equal to k, what will we do? We'll do, see here, let's say we are here, we are at this point, we have increased the count to 1, we move back again, increase the count, move back. What we want to do here is not move this way, but move this way, because we went this, we have never counted this one. So what we will do is move this, then go like this, and then this, right? Even at this point we are not directly going here, we are going here, we're coming back to this point, and then we are going again right and coming back again, right? But since we don't have anything in the right, we just return. Okay, so that means here we need to move right. So DFS of node dot right. At the end we do DFS of root, basically starting the DFS recursion call, and then we return result. Okay, let's see if this works. Let's submit it. And it is working. So let's do a dry run again while keeping this code in mind. Let's see how this works, right? So okay, let's begin with the easy one first. We are here starting with this point, right? Starting with this node. What do? Node is not if equal to nil, we return, which is not, right? So we move left, that means we move here, done. Again this call runs, it is not nil, we reach again this statement, we move left, that means here, and here it is null, right? Now we are in this statement where we have reached a null, the node is null, so we return simply. We get to this statement, we have passed this statement, we move past this statement, and we reach here. Okay, now count will be increased to 1, so let's give count was initially 0, now it will become 1, right? It will become 1. Okay, and since we have returned, if you remember, we have returned here, so we are not actually here, but we are at this point in this node. Okay, and our count is 1, which is equal to the kth value here, right? So that means we can, what can we do? If count is equal to k, result becomes node dot val, that means the result will become 1, and we'll return that result, right? The DFS call will end there. But just for the sake of learning, just imagine that the answer is 3. Let's say the k value is 3. Okay, so k is not 1, but k is 3. So what do we do next? We have not yet got our answer, right? So that means we have passed this part now, and we have reached this part when we go to the right. So that means from here we'll go here. Good, we have passed this. We again enter this function recursion call, because a new recursion call is being made. The node is not nil, then we go left. From here we again go left, we reach a null, so we return. We go right again because this time, okay, we have returned this, so count increases. So now count will become 2 instead of 1. Count is 2, but it is still not equal to k, right? So this part is skipped and we move right. That means from here we go right, we return directly because it is null, right? Now we have reached this. Now since we have moved to the right and return from there, so it's like this. We did this, we enter the recursion call, we returned using this, then we got out here and we'll move out of this recursion call as well. That means we'll move out like this. Again here we are returning from the right call because it was the right call of this part, right? So we'll exit the function again here as well, so we'll return again to this part, right? And this was the left call for this root, this node, right? It was the left call, so we are exiting from here this time and we'll reach this part. Here it will become 3 and it matches with the k, so we'll return the answer here, right? It's a bit complex, but try to do the dry run yourself and you'll understand. Let's do the dry run here as well. Here the k value is, I think, 4, 3. K value is 3. Okay, the k value is 3. So okay, we'll have a count variable here as well, and initially it will be 0. Now we are at this point, we move left, move left, we move left, because every time we encounter this part, right? Now again we move left, but this time it is null, so we return here. When we return this return, that we move up, it is we are exiting from this part, so we'll encounter this part now, so the count increases and it becomes, count becomes 1. Okay, then it is not equal to k, of course, we encounter the right thing, so we move right, nothing, we move back up. Here when we are exiting again, we are exiting from this statement, so in this time when we move forward, it exits from the function itself, that means the previous recursion function, right? So that means we are going back, and for this we are returning the left call, so that means we are returning from here, and so we encounter this part. It increases the count to 2, right? Still not equal to k, we move to the right side because that's what we get after the count, nothing, we move out and we move out of the right call and we exit the function again to this one. Now this is the exit for the left part, so here again the count will increase because we are increasing the count only after the left part, right? But when the count increases, it becomes 3 and we return the answer, which is this node, right? The answer here will be 3. So that was it, that was the dry run. Try doing it yourself, it will be much clearer if you do it yourself. This is the code. Thank you for watching and I'll see you in the next one.